So we're going to do law of cosines today, so you're going to need to take notes. I'm going to also make a film of this so you can go back and watch it if you have any questions. So not only do we need law of cosines, we need Hero's formula. Now I know it looks like it says Heron's. This guy dude's a Greek guy that came up with this formula. It's another area formula for triangles, but his name is pronounced Hero's. Okay, the N is silent, so Hero's formula. So we are going to have, again, we're having a test on law of sines and law of cosines next Thursday. So these law of cosines is going to be also any kind of triangle, not a right triangle. This works for all oblique triangles, and it works for 90-degree triangles. So we got this deal here. For law of cosines, only use for side, 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 or side, angle, side. You're only going to use it once. Now that's when you're given the three sides of a triangle, or you're given the side, angle, side of a triangle. And you're only going to use it once. Anybody want to guess why? I've already told you. Does anybody listen? Why are we only going to use it once? Anybody got a guess? Why would I only want you to do it one time and then go back to law of sines? Why do you think I'd want you to do that? Because it's longer. This takes longer. It's a little harder. A little longer. So law of sines is pretty fast. You got a proportion on law of sines. This one's a longer thing. So here's how this works. Depending on the angle is the key on which one to use. The angle given to you is the key. Did you all write that down? Some of you are spacing. The angle is the key on which one to use. So if you're given angle A, you're going to start with little a. So A, it kind of starts like Pythagorean theorem. It goes A squared equals B squared plus C squared, kind of like Pythagorean theorem, but it's not. You getting all this down there? Okay. And then it goes -2. And then these same two things, B and C, the two sides that are there, and then it's the cosine of angle A. So whatever angle's out here, the lowercase letter is going to start in the front. Well, that's how I memorize it. I remember it as being starting kind of like Pythagorean theorem. So the other one could be, you could be given the B. So you'd have B squared here, and then it's the other two sides squared added together, just like kind of like Pythagorean theorem. And then it's -2, and those same two sides, cosine, and since you start with little b, that would be angle B out there at the end. And then there's one more. There is C squared, which is going to equal the other two squared added together, -2 times those same two, and then the cosine of C. Now, I don't know, sometimes we give a formula sheet with these. I don't know if we're going to give you a formula sheet or not, but these are the easiest to use on side, angle, side given to you, because that fills in everything over here on the right. Okay? Now, sometimes they give you side, side, side. So what I'm going to do is I'm going to solve these equations when you're going to have to find these angles over here first. Because on the old formula sheets, Miss Moore wrote them and let cosine A be all by itself. Okay? So I'm going to solve these for cosine A. So by order of operations, you would have this A squared here, and then you would subtract the B squared and the C squared, because you got to subtract those over, and then you would take and divide that by -2BC. Okay, now, and then that would leave cosine A over here. That would have cosine A all by itself. Yes, ma'am. I can, yes. Okay, I'm going to go over here and explain it. So, let's do a new picture. So I have A squared equals B squared plus C squared minus 2A, or sorry, BC cosine A. I am trying to algebraically get this as my variable all by itself. So you have to, just like if I have 2x plus 4 equals 8, what do you do first? You get the numbers that are added or subtracted to the other side, right? So this number b squared and that number c squared are both added. So I have to get them to the other side. So I am subtracting b squared and subtracting c squared from both sides. And when I do, these cancel out over here, and I get a squared minus b squared minus c squared equals, and the only thing I'm left over here with is negative 2bc cosine A. Y'all see that? Now, just like here, I'd be left with 2x equals 8. Because these cancel. Oh, not 8, 4, sorry. I can subtract. Then what would you do over here? You get rid of what you're wanting, what's with what you're wanting to get alone, right? So over here, do you remember this is what I want to get alone? So I'm multiplying this by negative 2bc. So I'm going to divide this side by negative 2bc. I'm going to divide this side by negative 2bc. So over here, the negatives reduce, the 2's reduce, the b's reduce, and the c's reduce. So I've got cosine A over here by itself. Now, she does something right now that might freak you out. If you want to leave it like this, you can, but she does something else. She goes ahead and divides everything in the top by negative 1, because there's a negative 1 times 2 here. It's a negative 1 right here. There's a negative 1 right here times that 2bc. So she divides everything up here by negative 1, which makes b squared positive and c squared positive, and makes the a squared negative. And she writes the formula like that. In other words, she divided everything by the negative 1, so you don't have a negative in the bottom. Yes. Just to not have the negative. So on the formula sheet, she writes it like this in the blue. And I'm not even sure we're going to give you the formula sheet. Do you guys want to get rid of the negative or leave the negative in? Because I'm worried if we use the formula sheet, the negative might screw you up if we take it out. Yeah. Well, if we use the formula sheet, it's going to look like this. Would you like to practice what it looks like on the formula sheet? Okay, so I'm going to come back over here then. I'm going to come back over here and I'm going to change this around because I'm going to divide that by the negative part. So when I do, you're going to have, let's go back to red. You're going to have b squared plus c squared minus a squared over this. So that's if you're going to find A. So now the rest of them are the same method. Cosine, if you're dealing with angle B, if you're given 3 sides and you want to find angle B first, okay, you're going to have a squared plus b squared, plus c squared minus b squared all over 2ac. And the last one would be cosine C is going to equal a squared plus b squared minus c squared all over 2ab. You're going to use this one when you have side given to you. Because we got to find the angle first, and these are the angles. Okay, now I'm going to tell you something really important right now. You ready? This is really important. When you're given the 3 sides, you want to find the biggest angle first. Find the biggest angle first. You need me to explain to you why. Do you want to know why? Okay, here's why. When you do cosines, you can find obtuse angles from inverse second cosine. Because when we get to this point, we're going to have to hit second. You with me? Everybody, come on, pay attention, please. I need about 2 or 3 minutes right here on this part. When you get to this part, we're going to have to do second cosine, which is the inverse cosine to get the angle by itself. So we're actually going to be doing the inverse cosine of this thing over here. And cosines will give you an obtuse angle. Cosines will. And then when we're done with that, we're going to go back to law of sines. So if you get the obtuse angle from cosine, law of sines will not give you the obtuse angle. You remember that when we hit the sine of 40 and the sine of 140, the supplements gave you the same angle? Right now, real quick, hit sine of 140 in your calculator real quick. Everybody, type sine of 140 in your calculator. Did you bring your calculator today? So instead of writing me a note, what could you have done yesterday? Could you have said, hey, Mr. Woodrow, my calculator's home. Can I borrow a calculator? Yeah. Could you have done that? Yeah. Well, I don't understand why you didn't. Make sure the mode is in degrees. Everybody hit sine of 140? Yes? Okay, what I want you to do right now is hit second sine. We're going to find the angle. And then hit second negative sign, the answer. You're going to put that answer you got in. And then hit enter. Did it give you back 140 for the angle? No, it gave you 40. It gave you 40, right? Now, the reason it gave you 40 is this. It goes back to the unit circle. The unit circle is huge. Here's why it works for cosine and not sine. I don't know if you guys care to know this, but I'm going to tell you anyway. Okay, so you know, I hope that sine theta is the y value around the unit circle. Cosine theta is the x value around the circle. So when you go from 0 to 180, the angles, again, go all the way around our special angles, go all the way around like this. Sine does not know because the y value at 150, the y value at 150 is the same as the y value at 30. And when you hit second, if you have second sine of 0.5, it'd be the same on both. It doesn't know if you want the 30-degree angle or the 150. So they give you what's called the principal values. And the principal values for sine are from here down around to here in the first and fourth quadrant. So it's possible to get negative angles. They would give you negative 30 going this way and negative 45, negative 60, negative 90 instead of, this is 330 degrees positive. These are equal angles. Okay? Remember doing coterminal angles where we added 360? You add 360 to this, you get this? So your calculator will give you the angles in this. It doesn't give you obtuse angles. But cosine gives you answers from 0 all the way over here to 180. Those are the principal angles for cosine. So if we find the obtuse angle for cosine, it's over here in the second quadrant. So if I find the cosine, the biggest angle for cosine first, then all I got left, remember how many obtuse angles you can have in a triangle? One. All I have left are acute angles. So the law of sines will give you the correct answer after that. How many are thumbs up with why I'm telling you to find the obtuse angle first? It's because cosine will give it to you. Yes or no? Cosine will give you an obtuse angle on your calculator. Okay, everybody right now, okay, let's look at this. Let's go back to the unit circle and let me show you. We did sine of 140, right? And we got some decimal answer. I don't really care what it is. And then we did inverse sine of this decimal answer, and we got 40 degrees out. So I'm trying to show you that the sine is only going to give you the angle in the first quadrant. Do you understand that? Because the y's are the same in the first and second, right? Now, what I want you to do right now is I want you to do the cosine of 150 degrees real quick. We got 0.707 something, right? No, what is it? 0.8660, blah, 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 right? Now, I want you to hit second cosine of that same decimal number. The second cosine of that number, and that gives you that the angle gives you the right answer, right? You all see that gives me 150, not 30? Again, cosine will give you obtuse answers. Sine will not. That's why you're going to do, when you have side, 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 you're going to use the law of cosines, and you're going to find the biggest angle first. You understand? Okay, so what I want to do is I want to do a problem with you, but you don't have very many problems to do. Does everybody did not get this worksheet yesterday? Everybody not get this? Okay. So on the back, you're doing that back side today, and we're going to do one of each kind of problem. You didn't get it. We're going to do one of each kind. I guess I'll just do them from this sheet. We're going to do one where you got an angle. We're going to do an angle, side, angle, and we're going to do a side, side, side. So we're going to do number one, and we're going to do number two. Unless you guys want a different one, I don't care. You want a different one? Number one and number two. Okay, so we're going to do number one. Oh, I forgot. I also got to give you Hero's formula. Okay, we're going to do Hero's formula right now. This is when you have side, side, side on a triangle. This is what works for side, side, side on a triangle. Okay, there's a variable s that you have to find first. And you get the variable s by adding the three sides of the triangle and dividing by 2. That is not the area, that's a variable s. So you take the three sides, you add them up, divide by 2, that's going to be your s. And then the area of the triangle is this formula. It's a big, long square root. And it's going to be that s value, and then you're going to take that times the s minus every single side of the triangle. So that right there is Hero's formula, and that will give you the area of a triangle when you have three sides. Thank you. Here, you were here yesterday, right? You have a worksheet. But you didn't ride a bus? Okay, you're going to want to go back and watch this video when you get home, okay? So this is Hero's formula, how to get the area of a triangle given three sides of a triangle. That's an oblique triangle. If you have a right triangle, do 1/2 base times height. This is for a triangle that is not oblique, or it's not right, it's oblique, meaning not right. Okay, questions? And yeah.
What's that?
S is just the value of the three sides divided by 2. The sum of the three sides divided by 2. Okay, we are going to do number one, and I want you to find all the missing parts, and then I want you to find the area on all these because you need fraction that's going to be on the test next week. So number one says A is 1.5, B is 2.3, and C is 1.9. So we got a triangle, and I'm going to draw it because, like I told you before, we are visual learners. So we got this deal right here. Three sides. Are we going to use the first three formulas I gave you, or the last three to find the missing parts, to find the first angle? We're going to use the last three, right? Now, which angle do we want to find first on this picture? B. Why is it B? Because it is the biggest one. We want to find the biggest one. So I'm going to move my cosine of capital B over here to the right side. I know I put it on the left. I think I put it on the left side before. And I'm just going to write the formula down that we just had. Okay, so that should be the formula we had on the other side, right? Is that right? formula? Yeah. So again, the way I remember this is whatever this capital B is, it's the other two sides squared positive minus this same B that's over here, and then it's 2 times those same two. So all I'm going to do now is plug in these numbers where they go. So I get cosine of angle B is going to be 1.5 squared plus 1.9 squared minus 2.3 squared all over 2 times 1.5 times 1.9. Now, what do I got to do to get angle B all by itself? Anybody know? You take the inverse of this whole thing. So will someone please do that and then DMS it for me? We want you to DMS this. We're going to round it to the nearest minute because that's what you have to do on the test unless Mr. Fox changes the test. Somebody type that in? Oh, yeah.
I have 85 degrees.
Anybody yes, to the nearest minute is what it's always been on the test the last 5 or 6 years. Anybody verify that and got the same thing? If you're not practicing, you should be. Anybody verify it? Somebody get something different? No. Just keep it on your calculator. Did you get the same thing? No? All right. Well, then I'm going to do it with you. I get my camera on and move it over there. Oh, that's cool. I don't know how that happened. 84.15? Okay. Maybe did you say 84?
No, I said 85.
There, anybody else get 84.15? Yes or no? Did we all get 84.15? All right, well, let's do it on, let me get this camera over there. Do it with me, please. Do it with me, please, okay? You got my calculator. Okay, so here's what we're gonna, oh. What's that so dark? That is kind of crazy. I've never seen it be black before. Oh, there's why. I'm gonna shut this stupid thing off. Oh, man. I'll get that shut off. Okay, I guess I'm not going to be able to do it. So I'm going to tell you what to type in. So you're going to hit second cosine right now. Second cosine because we're finding an angle. Okay, now if you have a fraction bar on your calculator, you're going to hit alpha y equals 1. Is there anyone in here that does not have the fraction bar? Okay, so you're going to do this. You're going to put a parenthesis there instead. Okay? So everybody right now is going to put 1.5 and square it. Everybody. Plus 1.9 and hit the x squared button. Minus 2.3, hit the squared button. Now you're going to end the parenthesis. And then you're going to hit divided by. Everybody else is going to arrow to the bottom. And you're going to type in 2 times 1.5 times 1.9. Then arrow to the right and put a parenthesis there. And then hit second apps 4. Second apps 4 and hit enter. Now does everyone now have 84 degrees 15 minutes around it? How many? 16? 16 minutes, okay, let's change it. Everybody got 84/16? Look at the seconds. Does a second is a 30 or more? 38 rounds it up. Okay, so this should round up to 16. Did you get it too? Everybody got the right answer? Okay, now we're done with this. And by the way, you never have to check for a second triangle unless you have. What three sides do you have for checking a second triangle? Side, side, angle. This is side, side, side. We don't have to check the second one. Okay, now we're going to find the smallest angle next. It doesn't really matter because this is the only possible obtuse. It's not obtuse, but it could have been. All right, so we're going to come up here and we're going to use, and you're not going to use 84 degrees 16 minutes. You're going to use 84 degrees 15 minutes 38 point, whatever it is, point seconds. You're going to use that. Yes.
Why do you have to check the obtuse angle?
Okay, you have to find the obtuse angle using cosine because it does not work for sine. Remember where we typed in sine of 140 and got that decimal?
Yeah.
And then we did second sine of that decimal and it gave us 40 degrees? Sine will not give you an obtuse angle. Cosine does. And you only, there at most, you can only have one obtuse angle, right? So when you get the biggest angle here, the law of sine, we can go back and use law of sines now because it's way faster. Okay? So I'm going to use law of sines now because I'm going to find angle A next. So I'm going to get sine A is to 1.5 as the sine of B, which is this 84 degree. Now you're going to put second answer in here for what's on your calculator. You should have this thing, dot whatever's out there, over 2.3. So we're going to get sine A is going to equal 1.5 sine of that 84 degrees for 15 minutes, 0.38 seconds, whatever the depth. Not point there, the point's after the 38. I don't know what all it says. Divided by 2.3. Now that's sine A out here. So we're doing what we did yesterday. So angle A is going to be the inverse sine of this thing. So everybody type this thing in there and DMS it. And somebody tell me what we get, what this is to the nearest minute. What do you got?
40 degrees and 32 minutes.
Anybody verify that one? Anybody verify that one? By the way, this is the hardest one to do. This is the longest one. The one where you got side angle sides faster a little bit. Okay? Anybody get the same angle? Anybody get a different angle? Anybody get the same? Has somebody done it yet? So he's just that much faster than everybody else is typing on his calculator, huh? Amazing.
What's it say, 32?
Yes, 40 degrees, 32 minutes. Did you get that?
I got 28.
20. Everybody got 20. Did you use a rounded answer or did you use the whole decimal? That's why it's off. Okay, he used the rounded answer. He put in the 84 degrees, 16 minutes. So it causes you to be off. So this should be 28 minutes then, right?
Yeah.
By the way, does that make a difference?
Yeah.
I'll tell you something where it makes a big difference. Do you know our military uses guided missiles that they shoot at enemies? Did you know that? And this is what they use. The computer calculates this stuff using these things. And there's two radars up, or two satellites in the sky, and there's a human being on the ground, and they call it triangulation because they make a triangle to pinpoint. He takes a laser and he sticks it on what we're going to shoot at. And those coordinates are put into the computer that goes into this bomb that gets launched. And if you're off, you might kill civilians. And we don't look kindly to that. Other countries don't care, but we do. Yeah,
Up there, we would send A.
we don't send in that.
Times A over 115. Why did you?
That's not 115, that's 1.5.
Oh, okay.
That's 1.5 right there. I'm going back to law of sines. This is 1.5. I'm going back to what we've done for 3 days. Because this is faster than doing this. Now, yeah.
Can you show me how to put it in the calculator?
Okay. Do you still have that 84 degrees, 15 minutes, 38 seconds somewhere? You cleared it. Don't clear it again. You will not be able to get the right answer unless you go back and do all this again. Okay, so you're going to get what he got, because you're going to have to round it. So you're going to hit second sign. You got it? Hit alpha y equals 1. Then you're going to type in the top part, 1.5 sine 84, and I'm going to do it a faster way. Instead of putting them degrees, minutes, seconds in there, we're going to say plus 15 divided by 60 plus 38 divided by 3,600, 3,600 in parentheses, and then go down to the bottom and put in divided by 2.3. And now hit enter, or hit the end parenthesis, and then hit second apps 4 and enter. And it should be really close to this because I gave you 38 seconds. Okay? All right, now we got one more thing to find. What's the last thing? Angle C. What do you think we're going to do to find the last angle that we're going to do every time for the last angle? 180 minus this one, minus this one. And then we're going to DMS it. And again, you should not round it until the very end, but it really shouldn't matter. So will someone tell me what that one comes out to be? Should be 16. I think it should be 16. Yeah. Even rounded, it should be 16. Yeah. Okay. If you're that close, I'm going to count it right anyway. Okay, question. Now that's the longest one, I think. I think that's the longest, yeah.
Within seconds, we'll just have to do the rounded.
30.
Okay, well, it's 40.
Okay. I'm going to fudge it a little bit. The main thing is, can you use the formulas? All right, now we're going to do Hero's formula. I want to get the area of this triangle. So I have to find S first. So S is going to be little a. What's little a? I can't see it up there. It's 1.5, isn't it? Plus little b, which is 2.3. Plus little c, which is 1.9, all divided by 2. Will someone please tell me what this comes out to be? 2.85? Okay. All right, so there's S. Now, if I were you, you're going to hit a square root button. Okay, now you're going to type in your S. 2.85, and then you're going to go parenthesis, and then you're going to put 2.85 minus 1.5, because this is A, this is B, this is C. Then you're going to end that parenthesis, and you're going to do a new parenthesis, and you're going to put 2.85 minus 2.3, end parenthesis, new parenthesis, 2.85 minus 1.9. And then you're going to hit enter. What, someone tell me what that comes out to be, please. 1.4, we got 3 places.
1.47.
I can't hear.
1.41.
So this is a real little triangle. You only get almost 1.5 squares inside that triangle is all you get. And you should have realized it's really small because the lengths are 1.5, 2.3, and 1.9. Question on that. That's Hero's formula. Okay, we're gonna do one more, and I'm gonna have to get this thing going here. We're gonna do number 2. So number 2 says you got little b is 40, little c is 45, and capital A is 51 degrees. Now you're going to want to watch what I'm going to do because I'm going to do it faster than you guys would. So watch what I'm going to do before you start typing into your calculator, okay? So I would go first, I would write my formula down and I would put a squared equals 40 squared plus 45 squared minus 2 times 40 times 45 times the cosine of 51. I have just plugged in everything right into the formula that I gave you first. Y'all see that? And I told you not to type it in your calculator yet because that's not a over there, is it? This is a squared, isn't it? So I always take and I get rid of the square, which, how do you get rid of a square? We square root it, and this is a distance, so you never use the negative in front of the square root, it's only the positive. And I start off, so now you're going to type in the square root and type all this in exactly like it shows. You do not need the degree symbol on 51. You can just put 51 because your calculator's already in degrees, and we're going to get A right here. And I think maybe you'll see why this is faster than finding the angle one. The angle one's a pain. This one is faster. And we're going to have A right now. Now on your test, you have to write down that first thing because you get 1 point for that equation and you get 1 point for the answer. So make sure you don't just give me answers. Some of you do. I'm going to have to take points off. Yeah.
Use it right the equation. Use it right.
I'm talking this line. You must show me this line right here. That's worth 1 point that I can see you plug stuff in right. Okay? And then the next point is going to be whatever we get right here, rounded to 3 places. Will someone tell me what you got? So what you do is be wrong. What'd you get? You should have been able to type it in by now, hadn't you? 40.139. Anybody verify?
I got 36.871.
36.80 what?
871.
871? 36.871. How many of you got that one? So if you didn't get that, try typing it in again, just like I just did, right there. See if you can get it right. Maybe you left a parenthesis off or something. I don't know. I'd have to look. All right. Now do you see I have a side and an angle opposite? Do you see this? Okay, now there's another big rule that comes in right now. Are y'all listening? This is a big deal. I'm going to go back to law of sines, but what do I know law of sines won't give me? It will not give me an obtuse angle. So if you look up there, do you see that 36, 40, and 45 are my sides? What's my obtuse angle possibility? C. Do you see it C? So I am not going to find C. After you do this, you're going to find the smallest angle because we're doing law of sines. And I know the smallest angle out of what's left will be acute. So it'll give me the right answer. So see, if angle C is going to be obtuse, and I did angle C right now, I could miss it because my calculator in law of sines will only give me an acute angle. So I'm going to find angle B right now. So the sine of angle B is, and that's the smallest that's left over. I hope you know A is the overall smallest, because that's the smallest side. The sine of B is to 40, as the sine of 51 is to, and I'm gonna have that whole decimal there, not the rounded answer, whatever that decimal is. So I gotta take the 40, we're doing just like we've done for 3 days. We're gonna multiply the 40 over, and I'm not typing this in my calculator yet. I'm going to go ahead and get right here, and then I'm gonna type this in my calculator, so I don't have to type in more stuff. I mean, it's okay if you do, but I like just typing in my calculator once. Will someone please DMS that one? Will someone please DMS that one and give me what angle B is?
I got 57.8.
57 degrees, 28 minutes. Anybody verify?
Yeah.
Okay, great. Now, how many angles I got? 2. How am I always gonna get the third angle? If you do the 180 minus, that means that you can get an obtuse angle if it is. We're gonna take minus 45 and minus that one we just got, 57 degrees, 28 minutes, whatever else, and then DMS that. And what's angle C going to be?
71.32.
Okay, so we were okay anyway on this one. It was not obtuse, but just to be safe, you want to get the smallest angle first here. Yes?
45.
Huh?
45.
What about the 45?
I think you can 51.
Oh, it is 51. My bad. I looked at the wrong number up there. It's supposed to be the degrees. Sorry. Is it still 71.32?
Yeah.
Okay, my bad.
That's all you.
All right, that's what you're doing. Oh, we got to do we're gonna do a formula again here. Hey, what do I have right? And I didn't draw the picture. I probably should have. I got A, B, C. So let's see. A is 51, B is 40, and C is 45. So on this one, what would be the best way to get the area of this triangle? Anybody know? What am I given here? What's this called out of the sides? This is side angle side. Didn't we do a formula the other day that was side angle side? So if I were doing this one, I would do the side angle side formula, which is going to be 1/2 the 2 sides times the sine of 51. And you're going to have the area. Now, could I have used Hero's formula? Would Hero's formula give me the same answer? It would, except what would you have to be really careful of about this thing and these two? Yeah, if you use just 8.871, it will not be the exact same thing this one is. This one over here will be the right answer. This one will be a little off unless you use the whole decimal. Yes.
How did you find the obtuse angle first?
Up here,
Yeah,
because I was finding a side first. I was already given an angle. See, up here, I was given side angle side. So I already had everything over here, and I want to find the side first. Remember what I said over here? On the first notes, I said, if you're given side angle side, you're going to use these. If you're given 3 sides, you're going to find the biggest angle first. So I was given this on the second one. That's why. All right, I'm going to come around and spray. We're going to have